Hello ladies and gentlemen, and welcome to another Simple Learning 101 tutoring video. In today's lesson, we're going to learn about the atomic weight or the atomic mass of elements. But before we begin, we kindly ask for you to hit that like and subscribe buttons so that we can bring you more content tutoring videos just like this one. Also, don't forget to share this video with your family and friends, as they too might need help in their learning. Let's start this lesson by defining what the atomic mass or the atomic weight of an element is. By definition, the atomic mass weight is the mass of an atom of a chemical element, those found in the periodic table of elements, and we've seen those many times. And it is expressed in atomic mass units or AMUs. It's approximately equivalent to the number of protons plus the number of neutrons found in the atom or element in question. We can also say that the atomic mass of that element is the average number, allowing for the relative abundances of different isotopes. Isotopes will be talked about in a different video. You can click on the card above or the link below to know more about the isotopes. As I said about the abundance of different isotopes, let's take an example. There are three versions of carbon 12, carbon 13, carbon 14. On Earth, 95% of the carbon is carbon 12, which has an atomic mass unit of 12 AMU, carbon around 2-3% with a weight of 13 AMU, and a carbon 14, which is around 2-3% as well, with a weight of 14 AMU. The atomic mass number is found by adding the number of protons plus the number of neutrons in each element in question. Note that atoms are composed of protons and electrons and neutrons, yet neutrons and protons are roughly the same weight and size. Electrons are so small in comparison to the neutrons and electrons that they're not even taken into account in calculating the atomic mass of an element. Here, we see two equal size and weight spheres or circles. The one in purple is a proton. It has a value of 1 AMU. And the sphere or circle in the light blue is our neutron. It too has a value of 1 AMU. An AMU is a unit of measurement used to know the masses of an element, just like you use inches, meters, kilograms, and pounds. So to calculate the atomic mass of, or the atomic weight of an element or atom, we use the formula: the atomic mass of an element equals the number of protons plus the number of neutrons of that specific element. The answer is in AMUs, or atomic mass units, or the atomic weight. Note, this is a mathematical equation used when asked to find the atomic mass of an element if you don't have the periodic table of elements in front of you. Always use this equation. The actual atomic weight of an element in a periodic table of elements takes into account the average atomic weight of different isotopes, like I showed you, the C12, C13, and C14. Here we see the first three elements of the periodic table. Each element box shows the atomic number on the top left, right here, the atomic symbol right here, the atomic name or the element name, and at the bottom is the atomic number of that element, or the atomic mass or atomic weight, I should say. On top of each box, we see the number, we see protons, and we see neutrons and electrons pertaining to each element box below them. So this one goes here, this one goes here, and this one belongs to this one. Now, let's look at the first box. Hydrogen has 1 proton, in purple, 0 neutrons, and 1 electron. Its atomic weight is calculated by adding the number of protons plus a number of neutrons. Here we don't have neutrons, so The periodic table shows we have a 1.01 AMU, as it takes into account the average atomic mass of all the different hydrogen isotopes or versions of hydrogen, if any. So, number of protons is 1 plus 0 neutrons, and we have an approximate atomic mass of 1. Let's go to the next one. So the next one says it's helium. It has 2 protons in purple, 2 neutrons in light green, and 2 electrons in orange-yellow color. So if we calculate the atomic mass here, we should have 2 protons plus 2 neutrons, which equals 4. And as we can see, we have an average of 4. Now let's look at lithium. Lithium has 3 protons in purple, so 3 plus 3, 3 protons plus 3 neutrons equals 6, and we can see it says 6.94. This is because the average is taken from all the different versions of lithium because of the isotopes or versions of it. So we have 6.94, as some of these lithium isotopes are heavier. So remember, each of these atomic weights are in AMUs. Alright, so in this section of the video, we're going to go over the atomic mass or the atomic weight of each of the first 12 elements in the periodic table. So let's start from the left, right here. Hydrogen. Hydrogen has 1 proton, 0 neutrons, and 1 electron. So if we calculate these two together, proton plus neutron, we should have a total of 1 AMU. But we see we have a 1.01 because the actual periodic table of elements takes into account the different weights of hydrogen out in the world, or isotopes. Let's go to the next one. So we have 2 protons, 2 neutrons, and 2 electrons for helium. We should have 4 AMU as the atomic mass unit because we added the protons plus the neutrons. And as we can see, we do have it. Remember, the first one is the atomic number, the second one is the atomic symbol, the third one is the atomic name or the element name, and the bottom number is the atomic mass or atomic weight of that element shown by the periodic table. Let's go to lithium. So lithium has 3 protons, 3 neutrons, and 3 electrons. We add the protons plus the neutrons and we get 6 AMU. 3 plus 3 is 6. And we're close because we get 6.94. Let's go to the next one. So beryllium. Beryllium has 4 protons, 4 neutrons, and 4 electrons. Beryllium should have somewhere around an 8 AMU because 4 plus 4 is 8. As we can see, we have 9. Again, the isotopes. That makes it higher. Let's go to boron. Boron is the 5th element in the periodic table, and it has 5 protons, 5 neutrons, and 5 electrons. So boron should have an atomic mass unit of about 10 AMU. And boron actually has, it should have 10. Now, let's go to the next one. Carbon. Carbon has 6. We've already been through carbon. It has 6 protons, 6 neutrons, and 6 electrons. So the atomic weight should be 12 AMU because we added the 6 protons and the 6 neutrons. 6 plus 6 is 12, and we do have an average of 12.01. So we're close there. Alright, so the next one is nitrogen at the bottom. So we have here 7 protons plus 7 neutrons equals 14 AMUs. And we see we have 14.01, which is close. Now, the table says oxygen has 16 as the atomic mass units. Let's see. The number of protons is 8, and the number of neutrons is 8. So if we add those together, we have 16 AMUs. So we're correct. Now the next one. Fluorine. Fluorine should have somewhere between 18.99. And let's see what the answer is. Number of protons is 9, number of neutrons is 9, electrons is 9. So we add the protons plus the neutrons, and we actually get 18 AMUs. So yes, that is correct. Let's go to neon. Neon has 10 protons, 10 neutrons, and 10 electrons. The answer should be that we have an atomic mass for neon, or atomic weight for neon, of 20 AMUs. And we have 20.18, very close. Now let's go to the next one. Sodium. Sodium has 11 protons, 11 neutrons, and 11 electrons. So we do calculate the atomic weight of this element of sodium, and we have 11 protons plus 11 neutrons equals 22 AMUs. And the last one is magnesium. Magnesium has 12 protons, 12 neutrons, and 12 electrons. The atomic weight of this element is 24.31. Let's see how close we can get. So 12 plus 12 protons plus 12 neutrons is 24 AMU. So we are close to it. Again, use the atomic weight calculation only if you don't have the periodic table. But if you do, use the number given in the periodic table. Now, you could use this equation and this formula for all the elements in the periodic table. So, thank you so much for watching. We hope you enjoyed this video. If at any point you got confused, just stop, rewind, and replay this video. Don't forget to subscribe to our channel. Click on the video list and playlist to see all our content. Remember, you're never too old to learn. See you next time.